Hello, how's everybody doing? But yeah, I just wanted to do a chill stream today. There was quite a bit of stuff going on, so I didn't really have too much planned out, but I figured we could hang out, do some development together. I've been working on the next version of this MCP server just to get it a little bit more robust in terms of functionality and more dependable in terms of output. So yeah, I figured we could work on that today. There's a few changes that I've made already in terms of testing that I'll go over, and there's a few things that I've made it to be more dependable. So we can talk about that. So yeah, I'll go over kind of the changes I've made since we released this. For those of you who are not aware, this is basically a server that we use to integrate with large language models using an agent interface. And then this communicates with Binary Ninja over a HTTP JSON REST API in order to retrieve information from the database and then make changes to the database. So I've talked about this quite a bit, so I won't kind of beat it into the ground, but I'll link the blog post for those of you who are not aware. So we did a blog about this quite a while bit now, in April. And then that basically goes over the entire architecture, links to our previous stream on this, and then goes over kind of all the functionality that we've implemented in the past and this little like test interface that we created, etc. So I might make use of this test interface today because we're going to be adding some additional functionality. I wanted to add the functionality to be able to read globals because that's quite important. Obviously, when you're doing reverse engineering, you need to be able to read data from the database. So that's what we'll be looking at doing. And then there's a few other things that I wanted to change. So right now there's like this password API interface that we need to enter every single time there's a new reversing session. So I kind of wanted to see if we could remove that. And then also look at other functionality changes that we could get kind of feature parity with some other MCP servers. So like Duncan has a, let's see, Mr. Exodia. Duncan has this IDA Pro MCP server that's quite robust. So I kind of wanted to see if there's certain functions in here. I don't think so, but like list globals, what else? Get entry points. So like say we have a DLL with multiple entry points. Rename globals would be really good. Set function prototype would be really good. Declare C type, set local variable type. Like these are all things that we're missing right now. So yeah, so that's kind of what I wanted to look at. Okay, so let's go over the changes I made. Maybe we can just use Git for that. I added that. Okay, so actually this kind of looks bad. But basically what's super cool about Binary Ninja is the fact that it has the headless API interface. So it was really easy to write tests for this because I could effectively instantiate, that's my test environment. Let's look at these tests here. So I was actually able to load a test binary and they're using their headless API. And then I would instantiate an instance of the BinjaLattice API and then start a server in order to interact with the given Binary Ninja interface. And then basically able to not only perform or retrieve information or change the database in real time using the binary view, but also verify or extract information from the database in real time with these tests. So they're not really like the kind of fake HTTP API interface tests that you might see sometimes, but these are dealing with Binary Ninja directly and the BinjaLattice interface directly. So I don't know if you guys are interested in reading through given tests, but it's definitely an important part of having a stable interface to work with. So that's what I did. And then there was some stuff going on with the functionality for changing variable names. So I changed that as well. So let's see the variable name. So this function is now implemented correctly. And it just allows you to update a given variable name within a function. But what this does not cover currently is globals. So that's one thing I wanted to look at today. So I think we can probably start with doing that. So I'm just going to get this interface up and running. And I'm just going to use the Python interface here to do that because it's a little bit easier. So I didn't even know you could do this, but you can actually look at your history in the Python REPL within Binary Ninja by hitting Command R. And then I can literally like search backward through all these commands that I was using for development before, which is like super useful. So I'm going to use import lib. This is kind of the suggested way of developing Binary Ninja plugins. It just allows you to re-import a given library into the Binary Ninja interface without having to reload the entire Binary Ninja instance. So the reason that's important is just so we can actively develop our plugin here without having to reload an entire instance of Binary Ninja. We actually don't have this loaded already, so we don't need to stop the server. Control R, Command R is unbound by default. Yeah, sorry, did I say Command R? I meant Control R. Also start typing part of the command and then using it as a hotkey. Yeah, only Python. Okay, let's try this again. Okay, there we go. So this is one of the parts that I want to rip out, is having to establish a new API key every time because it's really annoying. But I'm just going to update my MCP config here. And so this is just this is all to do with cursors. So this is like the API interface, not API, but the MCP server config for local MCP servers that I'm using, which in this case, see every time I'm saving this, there's a post 200 auth. That's just cursor doing that. So it's probably monitoring for changes to that config. And the post 200 auth basically means we've successfully authenticated to our BinjaLattice MCP server. There's just like this dream state. I just have like YouTube open, so but I'll link the song. Okay, so I know for acquiring globals, there's a few things we can do. So I know there's like bb.variables, I think, vars, maybe not. I did this for some previous work we did. So let me pull up my stream notes. Oh, data vars. Cool, thanks, Jordan. So I think a really easy, maybe not the greatest way to do this would be to look up a given data var. So for example, like this global being assigned here. I think in theory, these globals will have unique names, but we can probably acquire it from the, current function. I can't remember if, so I'm just gonna print out the variables. And I can't remember if I don't think there's globals in the given function variables, which would make sense. But I'm just going to check that. Because I basically just need to give the automation a really easy interface for renaming a given global. But I think the easier way to do it is to just basically say, like, given a variable name change that the large language model is requesting, just look for the local variables and globals. I think there's probably some easy ways that we could do this. Again, I don't know how often global renames occur with the large language model, but we can probably add support for that just in case it does happen. So let's look at the variable access code right now for updating a variable name. Literally all it does in the implementation. So this is the HTTP interface, and then we have update variable name. So we have our update variable name handler here. So this is just like a really basic HTTP interface. I didn't really want to use any of this is probably a super ghetto way to do this because I'm actually just splitting on the REST API, the URI path or URL path in order to access each portion I need of the REST API interface. But I didn't really want to use an external library because then I would need third-party dependencies and blah, blah. This was a little bit easier. But literally all it's doing right now is it goes for var and func vars. It gets the variable name, and if it's equal to the given path, then it just sets the variable name to the new name. So pretty straightforward. And then in data is just the JSON data. So that's all that's doing there. But I don't think I've seen the instance where the variable name is actually global. But maybe that's because, let's see, I think I have a handler for get function variables. We might want to actually return the globals here. So but getting the globals within scope, getting the globals within the scope of the current function might be a pain. I could have sworn that in the local function variables there was the globals, but maybe not. I don't think so. Okay, let's see if we can probably get the cross references to data vars. Is there maybe I can look at the docs for this. Their docs are really good, so it's usually not too bad. Okay, let's do data vars, function. Okay, so we have the basic blocks, target list, create user variable, get all user var values. That's cool. Get high level IL var refs. That might be something we can use. Returns list of IL reference source objects that reference the given variable. The variable is a local variable that can either be on the stack and register or a flag. Okay. Okay, so that's for a given variable. So that's not what we want. But we probably want, so it's how the current API works is the code being accessed is pseudo C, which is basically a pseudo C representation of the high level intermediate language in Binary Ninja. So I don't think the globals will differ because they're data vars, but we definitely want to get variable by name. Oh, this might be a way faster way of doing this rather than that for loop that I was doing. What's the server you're building going to do? So basically it just interfaces, basically like allows large language models to interact with my Binary Ninja database. So I'll give a little demo of what that looks like in a second. But basically it's just a tool set that the AI can use to interact with the database. And I'm just adding some functionality to it. Okay, I like this get variable by name, because if I can just use that, that'd be super handy. So current function, and then let's say, I don't think this is gonna work, but let's see. Yeah, vibe reversing basically. Okay, so that doesn't work for globals, but I can definitely do that. This might be a quicker way, this might be a better way than doing what I was doing before. Let's just make sure it handles parameters correctly. Current function, parameter vars. Am I even handling parameter variables properly? Change, let's see. Update variable name, get function by name. Like I don't really have to change it because it's already working, but does func vars have the parameters? That's what I just want to make sure of. For v in, oh, this doesn't have any parameters, so we probably want to use a function that actually has parameters. Let's see, this is not as many. Oh yeah, arg1. Okay, yeah, so that does have the variables, so I'll probably leave that. Does this API function get variable by name? Hell yeah, nice, that's easy. And then v.name. Okay, yeah, that works. So why don't we do that instead of iterating over every single variable name? I think we can just leave it. But for the globals, that's what I need to do. bv.dataVars, get data. I was hoping there was a get data var by name because that'd be easy. But yeah, I don't even think we need to do what I was talking about, because if there's a given global, so say there's data 414130, then I can just iterate through all the globals. So let's see, get variables, and then we'll do, I just want to put this function definition next to this one. So we'll do get global. Let's see. Okay, I won't use the tab completion stuff because it's really annoying. Protocol.bv.global_vars. Okay, so for var in self.protocol. So this is actually going to be the bv.datavars, and then result.append, and then we need the name. So is that, let me just make sure that's var.name. This is a generator, bv.datavars. Okay, so we need this is a dictionary. Let's do a list. And then we just want the first entry to test with, and then is that just gonna be an address? It is. Let's still make sure that's what that is. Yeah. Why does it give me the list for that? Or why does it give me the address when I turn into a list? That's okay. Let's do this. Say a.name. I'm so confused. Let me look at the binary view API. And then we have the, okay, so it's a list of data variables, and then and then this is a mapping. So it's a collection. Okay, so can I do like, oh, that's why I understand now. So if we do items, and then we do kv, print v, okay, so then we want, okay, variable. The first variable is the DOS header, which is funny. Okay, so then let's do a.name. All right, pretty straightforward. So a.name, let's see what else we got. So var dot, so that we actually want this to be items, and this will be address, and this will be the var information, and that'll be var.name, that's correct. And then we actually want these are all the same properties as local variables. So var, oops, type, yes, immutable struct. Okay, so it'll be location will actually be the address, and then var.identifier. I assume this also has a identifier. Maybe not. We don't really need the identifier. So the one thing that I found when I was working with these large language models is that they're not very good at handling numbers or like hex in general. So basically everything in this MCP server just works by name, because the MCP server would be like, yeah, I'm working on this function, and I would use it by address, and then the large language model would get confused and then start working on some other function because it would screw up the hexadecimal address. So that was kind of funny. But so we don't really need the identifier, but we definitely need the location. So okay, so get global variables, and then we're going to use get variable names, do that, and then we need get variables, okay, global variables. So now our get function, it doesn't really make sense because the get function variables is returning all the globals. So that's kind of what I meant, that it needs to be within context of the current function. So I'm trying to figure out how we can do that. Let's see. Are they only accessible within the data variable, or within the binary view, within the global context? Like I could write something more complex to get the, like the only way I really know how to do it is to iterate through the entire function and then look for variable references. So something like operands, or this is better. Let's do like source and then, or dest. Be high level IL deref, and then, yeah, I didn't think that would work. And then operands, and then it'll be a high level IL const pointer. So do we really have to look up like every single pointer in a given function and then see if it maps to a given global variable name? Like that would kind of suck. But maybe that's what we have to do. Because will there ever be an instance where it's not a high level IL const pointer? I don't know. But yeah, I guess we can do that for now. It's not too difficult because we can use traverse. So I can do something like get, let me see, because once we get the operands 0, here, let me see what I did in the code for our previous stream. So for those of you who are not familiar, every single time I do one of these streams, I upload these stream notes to our GitHub, Invoke RE/stream notes. Let me link that. And usually I get something I get some things that are worth sharing. So for automation. So I'll just link that in the chat. There's the stream notes there. And the one I was curious about is the SteelC one, because we had to rename a bunch of globals. So let's see if I can find where that was. Target function. Okay, we're gonna need that in just a second, so I'll use that. But basically we needed to rename a bunch of globals. So that's what I was looking for here. Callers containing blah, blah, blah. Rename global, define user symbol. So I don't know if that's actually what I have to do, because I think once I have the data variable, I can just rename it. But let's give that a try. But was I finding the globals in a different way? I guess not. I was just basically getting the destination operand, rename global, destination address. Oh, and then I was just defining the user symbol at that address. So that's not really what we want. But could I not get the global name from that? Let me check. Let's do, okay, so that's probably kind of a ghetto way to do it, but, and then just do like we could do like this. So re.sub, and we'll just get rid of the ampersand like that for given input. And then we have the global name that we can look up against our list of data variables. So we'll just do something like that. So what I was talking about with the, let's see, with the traverse. So this is kind of more advanced, but in the Binary Ninja high-level intermediate language, so they're like decompilation. These are made up of nested objects, nested high-level intermediate language objects. So you don't really want to traverse these one by one until you get the value that you want to work with. You want to do it recursively. So they have this really nice API called Traverse, which I'll be using for this. And I've used many times before because it's really easy. Well, not easy. It's just an easy way to get a specific object type that you want in a given function. So what I'm just not so sure about is if global, I'll figure it out. Because if it's a high-level const pointer and the names overlap, we'll figure it out. I think I can look at the, yeah, I think I can do it by address. So let's do that. But okay, so back to what I was talking about. Basically, we can recursively traverse the decompilation. You can do this in IDA2 with their tree structure, but you basically can take a given instruction. So let's say we do it here. I'll implement it as I go. So let's say def get globals from func, and then I already established that this is BS. So maybe I could turn off the auto completion, disable globally. There you go. It's useful for like boilerplate, but so get a function, and then if we have a given function in this context, it'll be get function by name. So we'll already have the function to acquire stuff with. And then I need a callback here. So for our recursion, so it'll be like is global pointer. And then we have our, let's see here. We actually might have to make this a class variable. Or sorry, actually no, I think this should be okay. Okay, so we'll just do, I'm just gonna copy this from our code before, and we're going to want our object, and we just want to check if it's a high-level IL call, and then I think we're going to need to import that into our plugin here. Wait, we want to return the actual object. Return obj, and this should be obj. Okay, and then we need to import that. Unless I'm importing, I can't remember if I'm importing all the Binary Ninja stuff. I'm not. Oh yeah, I'm never. Okay, yeah, that should be okay. I need to add that to my, I need to add the Binary Ninja API to this, but, and then this is going to be high-level IL const pointer. Again, I'm not sure if that's going to be the case for every single defined global that is referenced by a given high-level IL function, but let's just assume it is for now. And then we're going to do func.traverse. Oh wait, it'll be traverse. Sorry, I just can't remember. Oh yeah, we're traversing the given instruction with our callback. So we're going to do func. I think this is going to be each basic block, but let me double check. Yeah. And then we'll do for instruction in basic block. So the cool thing about Binary Ninja, for those of you who are not aware, Binja has even even basic blocks within their high-level intermediate language representation. So it kind of makes it visualizing things a little bit easier depending on the code. In this instance, not really, but it's really useful for automation. Okay, so instruction.traverse, and then I'm going to add my callback to this code. So what I usually do, for those of you are not really sure what I'm doing, basically I'm POCing this within my little REPL interface here, and then I just add it to my plugin code, so I don't have to like redo this all in the plugin code, or like implement it in the plugin code and then test it, because then we're gonna have to reload it. So I'd rather just POC it here and then test it with the plugin code after. But because this is Python, we have these tabs and it's annoying. We don't want that because we have self here, and then we'll do that for loop. So for BB in current function. Hey, y'all doing? Doing all right? We love traverse. Yeah. All right, cool. For BB in current function, for instruction in BB, then we want to do instruction.traverse, and then I think I just need to provide the callback. So his global pointer tuple has no, what? Why is it a tuple? What? Why is the current function? Okay, I need to do current function.hlil. Right? Yeah. Okay, there we go. And then, yeah. Oh, I can just do current IL function. Whatever, doesn't matter. Same thing. Dot HLIL. Okay, and then for instruction, and then we just append the generator results, right? Let's see. Do I have to list the generator? Okay. Why is this function name a high-level IL const pointer? Whatever. Because it doesn't really matter. So let's clear this. I'm gonna redo that. Let's do res is equal to that. So okay, so this might be really confusing for those of you who are not super familiar with what I'm doing. Basically, what I'm doing is the current function has like a whole bunch of instructions, and then do you have the snippet plug? I do, SETI. That might be better than just trying everything from the REPL. Let's do that. Uh-oh. Don't crash, please. Okay. I don't know why that just happened, but let's do get func globals. I think we're good. Okay, let's do this like that. And then I just need that callback. This one. Okay, so I'll explain what this code does. So literally all I'm trying to do is get all the global variable references within a given function. So as I mentioned earlier, there's like these nested high-level intermediate language objects within Binja. So basically all I'm doing is I'm using this traverse function to provide a callback, and all this callback does is it looks at each object and then checks if they're an instance of high-level IL const pointer. And the reason I'm doing that is because each of these global references is a high-level IL const pointer because they're just pointers to a given global. And then if I run this, wait, we don't have res yet. And then I print the results. I think I need to fix that append, but oh, why did that music just cut off? There we go. Then we basically get a list of all of the pointers within a given function. Am I just getting them over and over again though? Oh, no, not. Because sometimes there's going to be multiple pointers within a given instruction. So we're seeing that like each call in this case, like the sub 404C50 is also a pointer. There's like a string to debug. Let's see, is that a global? Yeah. So yeah, there's a bunch of pointers in here. So the only other thing that's kind of weird, and I don't know if the AI will be able to understand this, is like if you have this wide string reference, for example, I don't think it'll understand in the output that it is a global, but maybe we can cross that bridge when we get there. So this is kind of complicated, a little bit more complicated than I thought, but okay, so let's use this. So it's a list of lists. So I don't know if I can just do that and it'll fix it. Okay, so I didn't want to keep, like I didn't want to have a two-dimensional list. I just wanted all of the given variables. And then I think I was kind of wrong in that I could just use these data names, but I don't really think we have to worry about the, like I think we'll have to match by address, but that's okay. Okay, so let's add this. And then this is actually going to be a high level IL const pointer that we're returning here. And then the object is going to be any, right? I guess we can do that for now, or we can just leave it out. This is what we call fun. All right. Okay, so let's do, yeah, this is correct, right? I established that the callback was correct, and then we just want this in our function. I'll do self dot as global pointer. And then for current function, we actually want func. And let's get function by name returns a high level IL function, which I think it might, what's the MCP? Basically, it's this protocol that Anthropic made to give large language models or like AIs access to tools. So basically, I'm writing a protocol for LLMs to interact with it. On model context, yeah, exactly. So I'm working on a MCP or model context protocol to interact with this like reverse engineering program to help us reverse engineer stuff. Yeah, it's definitely ambiguous for sure. Okay, so get functions by name. If we go back here, I actually do think we need the high level IL func.hlil. Yeah, that's fine. Okay, and then we kind of want to map these, right? Because we have our get global variables. Okay, so res. Okay, so we have our res here. And then for each of these, we just want the name of the variable, and then we're going to map them to the global data variables, because I don't know a better way to do this, but maybe there is a better way. So we can do res.append. Okay, we actually want for r and res, and these are going to be, right, the pointers. So I'm just going to do like string r, and then we'll have the gvar name, and then we can literally just say like, unless we can do like dot name or something, but I'm pretty sure I tried to do that before and it didn't really work. I think operand just gives me the test. I think it just gives me the address. There has to be the name somewhere in this though. I wish I could just get the name of the pointer, but I guess I could just get the address of a given pointer and then map that to the global variable address. I'll probably just do that instead of doing this stupid string substitution thing. Yeah, let's do that instead. So r dot constant to address. Are you on your own projects full time? Yeah, this is just one of my like fun open source projects, but we do malware analysis training. So it's like this stuff. I'll link that. So this is the largest part of the startup right now that I'm doing is the training. And then I'm trying, as I have like more time now, because I'm doing this full time, I'm trying to learn more AI stuff. So that's why I'm working on this MCP protocol. But this is all free and open source, so I'm not making money from this. It's just fun stuff to work on. Okay, so r equals constant, and then we're just going to do bv.datavars, and then it'll be for address var in datavars. Oh my god. Dot items, and then let's do g-address if I'll do found global, and then we'll say var. Let's call this gvar. Okay, it looks like none of those matched, so maybe I think in theory these global pointers should match. Okay, and then let's have, we'll just say this is the, and then r, like that. Let's see, for r and res, that should have worked. Oh, cool. Okay, yeah, something was just wrong with the output, because now that's showing. Sweet, yeah, it's finding them. So, okay, so now we're finding the globals within the local function context. I think we can go from there. So this will be, we already have that. So I'm just gonna add this for r and res, and then we'll return the variables. So res, so let's see, say globals, and then we'll return. Okay, I'm gonna append the found global variable. So it'll be gvar, and I just can't remember get function variables. And we're going to want to call this from get global variables instead. So yeah, it'll be jgvar. So this is going to basically be our new stuff here. And then we want this to be here now. And we'll call this result instead. Or we just call this gvar results. So it's more descriptive. And we'll just return gvar results. Okay. gvar.name, gvar type, and that will do g adder there. Okay, so that was like a super roundabout way of getting global variable references within a given function, but not 100% sure if there's a better way to do that in Binary Ninja. And then let's see what else we got here. So get globals. Now we're going to use get globals from func instead. And then we'll do func. Okay. I think I'll probably add the type stuff later. And then do we want to test this right now, or should I keep going and adding stuff? Maybe we want to test it. So I'm going to copy this plugin now to my Binja directory. And then since we already have the path to get to that code path, and by path I mean the HTTP path, this should all just work, hopefully. I'm lost, just following the flow. Yeah, no worries. It'll make more sense once I have everything up and running. Okay, so yeah, I copied that plugin over. So in Binja, I'm just going to save this because that's a very useful snippet, and I'll put that in our notes too, but this is going to be uploaded to GitHub with the project too, so you'll be able to see that there. So I'm just going to do reload. Okay, so this snippet, not snippet, but this code, when you're developing plugins for Binary Ninja, this is really useful because you can use import lib to basically just reload the Lattice server plugin in this instance. So basically all I did, I copied my Binary Ninja plugin. So if I pull that command back up, cool. So all I literally did is, oh man, sorry. I'm getting used to these hotkeys in my VM. Okay, let me just make this bigger to start with, and then I'll do CP. Okay, so literally all I'm doing here is copying this plugin into my local plugins directory from Binary Ninja. And then what's awesome about this import lib is I can do import lib.reload for my plugin. Then I stop the server, and then I start a new server, and that should all just work, hopefully. So let's do that. And then I could use a large language model in this instance to get the local variables for a given function. But let me just use the Lattice interface. So tools, and then I have this Lattice client. I actually think I need to use my virtual environment here. So test env. So I just set up my test environment because I needed some library dependencies that I already have in that test environment. And then I'm going to use the Lattice client. Get logger session ID logging.logger. What? Is this thing broken right now? I didn't know it. Let's check. Logging to get logger. Let's double check online. I can't remember. Do I literally just provide a name? Under underscore name. Sorry, I know I literally have Vim open, but it's just faster for me to work this way. Unexpected keyword, logger, get logger. Okay. Damn. I'll need to double check if that's just the library version that I have locally or what. But okay, so then I can use this little command line interface to interact with our Binary Ninja server that I just set up here. So I just need to provide the host, and then the port, and then the username. I'll just use user. And then this is the API key that I just set up in the log. Authentication successful. And then I need to do the interactive mode, and then 12 to get the function variables. And then for a function name, so I'll explain why I'm doing it this way in a second, but basically this just makes it a lot easier to, let's see here, local global variables. Cool, that worked. But the name is null, so I need to fix that. With the MCP server, it can be kind of a pain to debug because you need the LLM to call specific functions. So then in order to get around that, I just wrote this little command line interface to interact with the Binary Ninja HTTP server without us having to get the large language model to call these functions. So it looks like that worked, but we're not getting the variable names, and I don't know why. So let's figure that out. In this function, what function name did I use? This one. So let's see what the reason is for our globals not being, so we could probably use our little snippet here, gvar.name, globals, none. Okay, so that's doesn't exist apparently. So is it because it's still the default name? Like if I do, so annoying. And then I do like 0, 0, dict items not iterable. I thought that would flatten it. Okay, if I give it this address, then it should work, right? Is this giving me a flat array? For dv, bv.vars, get data var at. Yeah. You need to rename the vars to get a name. Yeah. Okay, cool. Yeah, that's good to know. So like, should I just format the name in the way that the large language model would pass it to the API? So like, I can say something like, if gvar.name, so if not gvar.name, then we'll just say name is equal to none. Let's say gvar. Oh, this is gross. Why can't it just give me the name? Should I do that stupid sub thing that I was doing before? Because I don't know if this will always be the same. I guess we can do that. R. Okay, I already have. You could always get the address. Yeah, so that's what I was doing, but like, do you think it'll always be the same? I mean, by that I mean like the same, I don't know, we can try it. So like gvar name. So we can do, might as well POC it in here. If not gvar.name, then we'll have gvar, or maybe there's some type introspection you could do. Yeah, I think I'll just do it this getaway and then we'll move on from there. Data like that. So this should work, right? Go back here. Then we have globals. Yeah, let's just do that. But is there a leading 0? No, there isn't. Okay. Cool. Yeah, let's just do that. So then we'll do var name is equal to none. And then we'll do this exact same thing. I might as well not type it all out again. Like that. And then we'll say else var name is equal to gvar.name. Okay. And then we're going to put our name here. Man, that was so bad. Maybe I can bug the Binja devs to make this less crazy, or just even implement something similar to this, because this was like way more work than I thought it was going to be. Okay, so now if I copy that again, so let's exit. What's the problem? Let's do that. Let's re-import this. I feel like there's a totally a way, surely, but usually I'm always used to name data variables when reversing. Yeah. Do you reverse with symbols a lot? Study. Okay, let's use our little test interface again. Okay, that looks good. And then let's do get local variables, or get function variables, and then we'll do this guy again. All right, look at that. Global variables, nice. Well, when I'm reversing malware or strip code or name things, yeah, totally. Okay, so now we got the globals, and then, so now the large language models will be able to get those, but also reversing kernel modules has symbols. Yeah, totally. Well, not the kernel modules that I look at usually, but that's on Windows. Okay, so we have the globals now. Now we have the global variables within the context of the current function that we're reversing. So then now we can rename those globals and then access them based on their address. So like now we basically just need to add this to our rename functionality, and then we're going to need to write a completely new handler for the global variable data access functionality. But I feel like we can do the rename functionality first because that's really easy. and then we can write something to access the global data. What I'm not too sure about is like, will the global data variable access API just return an arbitrary amount of bytes, or will it return like a sane amount of bytes? Can we access the defined amount of bytes at that location? Like, I don't know. Let me know what you all think. And if you don't know, if you're just coming around now, if you've just arrived now, basically I'm working on this server to let large language models interface with this reverse engineering application called Binary Ninja to help us with our reverse engineering efforts. So pretty niche, but it works pretty well. So I'm just expanding on this server to allow the large language models to do that. Okay, so let's do the variable renaming. And then I'll probably run to the washroom, but I don't think the variable renaming will take very long. So let's do that first. So let's do update variable name, and then we're going to get the name, get function by name. And then essentially if we get to this point, then we'll know that the variable name was not found within our local variables. So we'll do for var in, and then we'll do self.get global variables func, and then if var.name is equal to this, basically this exact same code, then we'll rename it. When I'm not sure about what the globals is, if you literally just do, we might have to do something more complicated. But let me add a comment here so that I'm not unsure about this later. So we need to handle the case where there's global variables, where is trying to change the name of a global variable. We need to find, and so in my other code, I was defining a symbol at that address, but I don't know if there's a better way to do that, but we might just have to do it that way. So let's see, for address and var, I just need something to work. Probably shouldn't be changing the DOS header variable name, but whatever. We can just do the last one. Like, can I literally just do a.names equal? Okay, cool. Yeah, that worked. Oh, and that happened to be a function pointer. So let's undo that. Okay, so I can just do get global variables. I don't really want to have to re-look up the variable object to rename it, but I guess I have to do that. So for var and get global variables, if they're equal, then for var gvar in data vars. This doesn't really have to be super efficient because it's, over HTTP and blah, blah, blah. So, but we could probably do a better version of this later. Self.protocol.bv, and then if the address, get global variables, var.address, then we rename it. Then we'll do gvar name is equal to, okay, we need to do this exact same thing. This is pretty gross. Okay, well, before I do that, I'm going to current, get that. We need to do this. Then we'll say current var name is equal to the new one, because we're getting that from the data up there. Yeah. And then this will be gvar.name. Okay. So I think that should work. So var.name, get global variables. This is providing the name. Oh, but we're not mapping them like before, right? Get function, get global variables from func. That's what we want. Almost called the wrong function. Okay, so then we are returning the name, yep. And then we're ensuring that that's the case. And then if we rename that, then we basically say that we successfully renamed it. And then it basically gets through both these for loops. Then we know that there isn't going to be a variable renamed. So then we return the error. Okay, so let's do that again. I'm going to go to my little command line interface here. Okay, and then we'll copy this, plug it over, reload it, and then Let's start up our little command line interface again using this key. And then we'll do get function variables at this function. Okay, so that works. And then if we rename one, give that function, and then let's rename this global. Oops, I did not mean to do that. I just updated the function name. Sorry, I picked the wrong function apparently. So let's update variable name. And then we need the other function. Variable name is the global. So I don't really know if the large language model will actually select the correct variable name, but if it's a global with this ampersand, but that's okay. We'll just, this is all brand new stuff, so we'll just work through it. Failed to update variable name. Let's see. Dictionary has no, oh, we need to, sorry, I just want to skip that song. So this var, this var.name should actually be a dictionary access because we're returning a dictionary. And then let's return this. And by return this, I mean, let's reload this. Then we'll do 5. Same thing, we're gonna update the global variable within this local function context. Okay, let's see what the issue is now. Oh, I forgot data items. Okay, let's do the same thing again. See, this is why it's good to have this command line test interface, because this would be an even larger pain otherwise with the MCP server interface. This would be faster, but it's not. Okay, let's update that variable name. Okay, what now? Oh man. Okay, variable name not address. Let's see, where's that? Here. Okay, that should be the last thing. Okay, let's copy that. Reload it in Binja. Copy this key, which I'm probably gonna get rid of because it's really annoying. We'll do the same test again. Okay, let's see what the problem is. Key error address. What are we returning from that API? And by API, I mean function. Var is get global vars, so let's check that. Location. Sorry, I know this is painful, but hopefully this is the last bug here. Location. Then we're gonna copy this, restart it, grab that address, and let's update the variable name again. All right, variable name updated, and then it did update accordingly. So got the global variables updating accordingly from the local function context. That took quite a bit longer than I thought, but whatever. Learning a lot along the way. So the next thing I want to do is, I'll write tests for that, but writing tests on stream is boring. So what we could probably do after this is reading global function data. But before that, we could probably test this with the actual large language model. And we can be like, yo, change these global variable names or change these variable names within a function. And then we can just get the MCP server to do that and the large language model to do that. It'll be a little bit more fun than watching me test with my local command line interface. Sound good? So I'm gonna be right back. So the reason we can do all these streams for free and upload all this content on YouTube for free is because I do this malware analysis training. So I'm just going to plug that real quick before I go. Hey Sergey, how's it going? PCAM. So yeah, check out our training, and I'm just gonna play a quick ad for that while I'm gone, and then we'll continue on with our dev. So yeah, check that out, and then I'm gonna play a quick ad for that, and I'll be right back. Hey everyone, my name is Joshua Reynolds, and welcome to the Invoke RE Introduction to Malware Binary Triage course. Throughout this course, you will learn to triage and reverse engineer malware binaries using a number of proven techniques. These include static analysis, which is the concept of analyzing malware at rest, and dynamic analysis, which is the concept of analyzing malware as it executes. We will also be analyzing network protocols used in malware command and control communications, malware obfuscation, packers and how to unpack them, process injection, how to write effective YAR rules to detect malware variants, and how to compare malware samples at a binary level. This course consists of 11 modules, each containing lectures and practical labs to apply knowledge that you have gained as you complete the course. We provide both video and written materials, so no matter what your learning style is, you can complete the course successfully. Thank you for checking out the course, and we look forward to teaching you. All right. Took off my sweater because it's hot in here, because my computer's shooting out hot air. All right, so getting code done, getting stuff done. I feel like this is a productive stream. So let's get the AI to do this instead. So the cheese grater, space heater, yeah, totally. So let's open up our little chat interface here. Okay, so for background, oh yeah, I need to add the API key. Oh wait, no, that's the token. We need this thing. So I'm just going to edit our little MCP configuration here. So basically how this works is I'm using Cursor for my editor, but also it has a built-in large language model agent. And an agent is basically just a application that can call functions or provide large language models the ability to call tools. And the way it knows what tools to call is with this MCP protocol. So if I go to this MCP server, basically these functions just tell the large language model how it can update the binary ninja database or how it can pull information from the binary ninja database. So that's literally all this is a defined protocol for the large language models to have tools to call. And then again, I'm going to be using Cursor to do that here. So if I open up a little chat interface here, so for those of you who have used Visual Studio Code and used their chat interface with the GitHub large language models, this is fairly similar. And I have this in agent mode, so that allows us to communicate with large language models. And I just have to add that API key to our Cursor config here. So I'm just going to do that there. And then we see the 200 auths here. So Cursor is actually monitoring for that API key change. And then we're getting the 200 auths, so we're good there. Okay, and then I'm going to say, can you list the variables for function? I can make this a bit bigger for you guys. For this function, we'll do a similar test to our little command line. And then it's basically called the get function variables tool. And then let's see, local variables. Did not get the globals for sub 404 E30, but I just added that to the protocol. So that should have returned it within the JSON. Okay, cool, yeah, I got them. Can you rename these global variables to be more descriptive or something? Okay, so it renamed the 414 1E4 to G critical section, and then data 414 E0 to G handle. Are you using lattices? For what? I just named it BinjaLattice because it sounded cool. Okay, so then let's see if it actually renamed these globals. Okay, and that worked. So, okay, so our global variable renaming is indeed working from the large language model interface that we've set up here. So, okay, so the next thing I wanted to do is see if we could get the global variable data access working. So let's do that. So for that, we can do, all right, so let's do the global variable access. So the only thing I wasn't quite sure of is the best way to define what data or the amount of data being accessed. So I don't know if this is going to be problematic in instances where, like, say it accesses global data outside of this global variable. Say it accesses like 256 bytes or something. So let's just do like this as an example. So in Binja, you can do like bv.read, and then let's just do 256. And like this will access data that's outside of this undefined section, right? So like I don't really know if we want to do that just because it might confuse the large language model. So I don't really know if we only want to give the large language model data if the global is well defined. So let me see if I can find like a string or something that would be global variable data for the LLM to access properly. So like these, right? Like this is a pointer to a pointer. I wish I could just give this kind of interface to the LLM, but I don't think that's possible. Current data var 414008, because this is like a pointer to a pointer, right? So this isn't really going to be great for the large language model to access. But like I wonder if I gave it this information, if it could actually access 401008 for 5 bytes. But there's like a limitation of the amount of data that can be accessed or that can be actually interpreted correctly by it as well. So, or even if it's going to call any of these, right? So anybody have any thoughts? But at least we figured out the way to resolve the local global references. That was probably the hardest part. But if I have, say I have this address and then 5 bytes, like that's just going to be another pointer. But if we know it's a pointer, then we do like bv.read, like this might be overcomplicating it. So like say the large language model wants to access a global, like the data at a given global variable, what would be the best way to do that? Because like there's going to be a bunch of instances where the global variable is pointing to data that's not structured, or in this case it's like a pointer to a pointer. Like this is a pointer to this value, which is a string. And these are all obviously going to be instances where the binary ninja heuristics have actually worked in order to define these strings. There's going to be a bunch of instances where it hasn't. And this is going to be accessing like random data at that offset. Is the type information out of the question? No, we could look at the type information. But then I'm going to need to write handlers for like pointers to pointers and stuff, which should be fine. So like, let's go to where this is defined. Oh, like this won't even be able to be accessible from the program. So let me find a better example. So this global, like I wish I could provide the large language model with like this UI. Is that possible? Can I programmatically access this interface? Probably not, right? Because I remember even to get like the pseudo C syntax from the view, it was like very involved. You can reconstruct it if you can traverse the IL tree. Yeah, like can I access, I don't think this is a get symbols. Yeah, maybe it's like maybe I can just write handlers for if they're pointers or not, and then go from there. So like our little snippet should work here to get the global variables. And then I want to get the 414001. Is this to resolve values of pointers in certain instructions? Yes, exactly. NPOV. Like not even resolving them, just accessing the data at those pointers. So like, for example, I would want the large language model to be able to read the data at this 414000 function, 414000 address reference, it to see that it's a pointer and then access this VSS string. So let me see, we could probably figure out a way to do that. So if I have the types that I was returning earlier, what was I returning for the types? The global variable types, gvar.type. So if I have, let's grab the API key here and use that here. And then if I do like get variable names for that function, 12, and let's use this one because this is a good example of something I would want to do in real life. Type void pointer, void pointer. Okay, cool, yeah. So we should be able to establish whether or not it is indeed a pointer. And then once we have the fact that it is a pointer, we can basically just access the address for that given pointer. Because if it's oh, this is gross. Let's just use the snippet. Okay, so then we have, because we're going to have to handle both 64-bit and 32-bit pointers. So if we have, okay, let's just handle this case to start. So it's going to be kind of gross because I'll be like, Well, first and foremost, let's set up a handler for getting data for a given global. And then we should be able to work backwards from there in order to define all of our required functions in order to access global pointers. So let's set up a handler. So we'll say, let's do the same format as this. So we'll do something like handle get variable data. And then we'll say address, or we'll say variable name. Oh, no, wait, we'll need to get the function. Oh, no, it'll be in the data. This will be the JSON data. So we'll say handle request to access data from a global address. And then we're going to have try, and then if not data or what was the, so I'm just trying to remember the REST API or the REST API format for the update variable name, because we kind of want to use something similar. So let me look at our library code now. So we're going to also need to update our library code. So what's kind of a pain is like every single time we add new functionality to the MCP server, we need to update not only the MCP server, but also the library, and then the plugin, and then the command line interface that we were using to test earlier. So it's kind of a pain, but it shouldn't take too long. So let's do, okay, then we'll have variable name, yeah. Okay, or name and data. Okay, global name is required. And then we'll get the function name from the path. Oh, that's the new name. So we actually don't even need the JSON data in this instance, I don't think, because we're just getting data. So let's get rid of that. And then we'll just have the path. But we need the function name and the variable name. So, okay, let's just copy all of this. Okay. Okay, so this should all work. But then we need to handle the globals too, again. Or actually, we're only going to be handling globals because the local variable data won't be accessed in this way. Okay. And then this is actually going to be our variable name. Okay. Okay, globals. And then, okay. Address is equal to location. Then we're going to have it, I think we need to access so we have the variable name. No, I think we have everything we need in the extra request, so that's good. And then the global name, gvar. So gvar location is going to be our address. Oh, the number of bytes is going to be in the JSON. And then we're going to have to encode this for the large language model to read it. So I guess we'll just encode it in hex. Or what would be the best encoding to send back to the large language model? Because like we start getting into the realm of prompt injection stuff, but I guess you can do that with the code anyways. So it'd be self.protocol.bv, and then I think the more uniformity, the better with a model. Yeah, but like say we have string bytes followed by non-string bytes, should we return all, like I guess we could just return a byte slice representation of the data, because then it'll show valid bytes or valid ASCII bytes. And do you know what I'm saying? But okay, before I like just try and figure out every edge case, maybe let's just get this working and then we can go from there. And then so let's do our bytes. And then the number of bytes are going to be from our data variable. So we'll say, I'm unsure. Yeah, it's all good, study. This is all a learning opportunity for us, for all of us. So we'll do data. Okay, let's do that error case again that I thought I didn't need, but now I do need here. And we'll say num bytes in the data. We'll just have to implement that later. And then let's add our exception handling at the bottom here, like the other handler. And then what do we need next? It'll be data num bytes. And then we're going to return the data in here. So let's just say it's our bytes like that. So if we say we access that global, right? And then we'll add the pointer handler stuff. So say we're accessing this. We access 4 bytes. Then that's going to return a byte string. And then if I format string that, then like, is that going to look bad? Do you understand what I'm saying? I think that looks okay. Like, do you think I'll just say like, let's say byte slice from global. And then let's implement functionality to follow pointers. But I wonder if I can do that from binja data var at a dot const. Man, I really wish data variables had the same properties. Code refs, data refs. Okay, maybe this is what we want. Here, let's do hex. No, maybe not. Data, code refs, address, data refs from. Oh man, there's got to be a way for me to get that pointer. Oh, that's cool. You can, there's an attribute that defines whether Binary Ninja found that automatically. Symbol. Immutable array class. Data refs, code refs. Yeah, I don't really think there's anything that we can use. That sucks. Like I wanted to see if there was a get data var at. Okay, void pointer components. Oh, cool. We can access the value, which will be the pointer value. Instead of, I was going to do a super ghetto way where I was going to like read the first bytes and then, or the first 4 bytes and then convert that to a pointer and then read that. But this is better. Okay, a.value. Oh man, no. No, yeah, that's right. Cool. Okay, so for pointers, you can do dot value and then get the actual pointer value. So here, if the type, and then I wish I could get the array length too, but I think I can get it at the destination address. Okay, so we're just gonna add code to automatically follow pointers instead of the large language model deciding, because I think that's easier. Like the pointer destination, if there's 2 levels of indirection. So we could do like, let's see, if var type. So this is another ghetto thing I'm gonna have to do. In var type. Oh, no, wait, we have the gvar, which means we have the actual binary ninja object. So I can do like if dot type, or we can even just say if dot value, I think, because that means it's a global. Then we'll just say get, no, we want address here, address. Then we'll do gvar, if gvar dot value. So is like that always gonna be the case with pointers? So let's try this one. Get data var at, okay, and then dot value. And then that points to what? I thought this would be, oh, okay, it's pointing the same. 401. Okay, yeah, that was right. Okay, so that's right. So if all these pointers, so if it has a value, like is there a way for us to, so if it's a defined array, should we override the read length that's provided by the large language model, or should we make it optional, or and I'm probably making this overly complicated. Maybe I should just say it can read from a variable. Okay, if gvar.value. Okay, let's just have it decide the number of bytes for now, and then we could probably edit that later. Because it's probably just going to decide like random bytes to read. Okay, so gvar, then our address, let's just say our read address is equal to none. If gvar.value, then read address is equal to gvar.value, which is going to be our pointer address, and then otherwise our read address is going to be our current address. Okay, and then we're going to read from our read address now. Okay, so I know this looks crazy, but it's just all has to do with accessing the globals. But now we're going to say if we have a global variable name in a given function where we get the globals from that function, then we're going to iterate through all the globals until we can find the binary ninja global associated with that name. Wait, hold on. Do we want to do... Yeah, we need to do by name because the large language models are bad with addresses. So, okay, so then we have gvar.value, read address. I think that looks okay. I'm just trying to figure out if I need to do this exactly this way. Yeah, okay. This is correct. So basically if we have the global address, yeah, okay, so there's two levels of things happening here. So basically I resolve the function by name that's provided in the REST API. Then I make sure that the global being accessed by the large language model within that function is available from our get globals from function. And then we match the function name. Then we get the binary ninja data variable. We match the addresses for those. And then if there is a pointer value, then we set that as the read address instead of the original address. And then if we have the pointer value, then we read that number of bytes. And then we say, this is the byte slice for that given address. Kind of crazy, but okay. And then now that we have a handler, we have to, so we'll do get, we have to provide that to our little path here. And then this would be in a get request. So we'll have, let's say, let's just copy this line. Ends with, and then we'll say global variable data handle get global variable data, because then we'll have the, and I guess we want get, we don't want it to end with that. Let's do it this way. Okay, global variable data, and then it'll be slash function name and then the variable name. So let's make sure that's the case. All right, so then we have -1, -2, function name, variable name, yeah, like that. Okay, and then we'll have our lattice library here. And maybe I'll do some tabbing here just so this doesn't take forever. So we'll do variable data, and then we'll have function name string, and then global variable name string. And then this is actually going to be our, what did we make the handler path again? Slash global variable data. And then it'll be function name, global variable name, like that. And then if response code is 200, I think that's all we need. Okay. And then we need to add this to our MCP server, and then we need to add this to our command line client. So maybe I'll add this to the command line client first, because I want to do that. Then it'll be function name, variable name, get global variable data, function name, variable name. Yeah, I think that should be good. All right. So why don't we test this with our little client interface first, and then I'll add it to the MCP server. And then we'll probably figure out the pointer stuff, but that should be good for now. Oh yeah, we didn't figure out the number of bytes thing. So let's do that first, because I made this a get interface, so we could probably do, let's make this simpler for the large language model, because this will be better this way. So let's just say this will be 256 by default. But then if the variable name is a pointer or is an array, then we'll get the array of that length. So let's say read length. No way. Does it actually have gvar.type.size? I doubt it. Yeah, I don't think so. T children. What does array do? Type count. Array type. Let's do children. I just really want to know if I can access the array length easier. than the crazy way that I was doing. There's got to be a way. Target. Get string. Oh, I see. All right, maybe we can just do something like that. Target.string. And then we'll just extract the length from there. There's got to be a better way to do that, but I don't know how right now. And then what else do we have? So if the read length is 0, okay, this is going to be our read address. And then we want gvar.target, and then the string, was it toString? Just the string of that target. And then we're going to access the, here, let me kill the tab completion stuff because it's really annoying. Then we'll get the pointer rep. I just don't know if it's always going to be in the same format, but whatever. Split on, ugh, this is gross. Like, I just want to do this, but I wish there was a way for me to access the array length that wasn't this. It's so bad. Like, are they all in this format? Const with that. What about this one? Get data var at target value. Okay, let's just do it as a fixed size for now, and then I'll handle this stuff after because it's taking too long. To do add global access size resolution or something. Okay, from pointer representation, pointer definition. And I should be able to find a better way to do that than parsing that array. Okay, and then the read address, so that's well defined, and then the rbytes. Okay, let's give that a try from a little command line interface. So let's copy our plugin over, and then we'll do reload. And then I'm going to try our little command line interface with our new API. Okay, now get global data. Let's give the function name. Okay, let's see what the problem was. Get global variable data. Let's see. Yeah, okay, that's why. Okay, let's try that again. This is like a pretty egregious debugging process, but at least we'll have something working by the end of this, hopefully. Copy the function name. Variable name. Let's see if we're to get global data. gvar.target. Okay, let's get rid of this handler stuff for now. Okay, let's restart this. Look at that, nice. Hell yeah, let's go. Reading global variables. All right, cool. Now let's get the large language model to read some global data, and then we'll see if we can get it to assess what is being read from the global. We could probably call it. Yeah, it is pretty neat, isn't it? All right, 15. Oh yeah, and then we have to add the MCP server definition. So let's do that. But yeah, this is global. This is following the global pointer, so it's pretty cool. Following the one level in direction. That's probably not going to work every time, but I think that's a good approach. And then obviously we need to define a proper length to read. And then let's get the MCP server function added. So let's do, I'm just going to use cursor to help me with this because it'll be faster. There we go. Okay. Okay, so how this works is we define an MCP tool. And then because we have our Lattice library here, that was the second thing that I was editing to actually perform the GET request using the REST API. And then the large language model is going to provide a function name and a global variable name to access data from. And then the, let's actually not return the JSON. We want the response to be well-defined. JSON.dumps, but what was the, oh man, did I clear it? Okay, let's try that again. Just to double check. I just want the, I usually don't like returning the values as JSON to the large language models, even though they can definitely interpret it properly, but okay. So once we have that done, it's going to provide status success. So we want to access the message in the MCP server output. Okay, yeah, we were just joining it before. So let's just do return response message. Yeah. Okay, cool. So that should be it. I don't know if I need to do anything in cursor for it to have access to that function. Let me open up the chat interface and do a new session. And then I'm just going to refresh the server and then edit our little MCP config. Oh, and I need to fix that 1 to 15. Let me do that real quick. Okay, cool. And then let's edit the MCP JSON to add our API key. Okay, the post 200 is working. And then let's say, can you get the global variables in this function and figure, let's just do this to start. 40407A0, get global variable data. Global variable name. So a large language model will try to use that API in a weird way. Maybe I'll rename it to get data pointed to. I don't know how I can like rename this in such a way that's going to be, let's see what Duncan did. Did he add debug stuff? Debug set breakpoint, debug list breakpoints, start process. No way. Damn, okay, I should definitely mess around with those debug functions. Okay, get current address, get function address, get globals filtered, get globals, list globals, bring global variables. Okay, maybe there's not really anything equivalent in here. I like the idea of using the debugger though. Is there? Cool, yeah, there's similar stuff in Binary Ninja, the debugger module. Okay, so let's try that again. Get global variable data, say get variable data, and then get data pointed to by a global variable name. Yeah, I feel like it's gonna, okay, let's see if I can figure out how to make it not get confused by this. Okay, cool, yeah, I found it now. 4140000, and then what data is pointed to by the global. Nice. All right, so that totally worked. These names are used in the function to enumerate and interact with these services. Okay, so I want to see if I can understand the whole function context here. Can you, okay, so can you analyze the full function in order to understand this context and understand what this data is used for? Okay, so basically it was able to understand that it's using control service, but it didn't get that the control service call that's used is to stop all of those services, but this is basically working. So let's ask it to rename those global variables. Can you rename these global variables to with this context? All right. Service names to disable. Cool. Yeah, so that worked. And then let's check the database to just make sure it actually did that. Yeah, cool. That worked too. All right. So we have a fully working MCP function now for not only MCP functions for not only accessing and renaming, for not only renaming global variables, but also accessing the data within the global variables and then understanding them. So that's pretty sweet. So that's kind of like all I really wanted to do today. Does anybody have any questions? I'm down to hang out for a little bit if folks are around, but if everybody's just chilling and don't have any questions, I'll probably commit this. I'm not really a fan of the default read length being like 256 bytes, but I'll figure out a way to parse the pointer length values. Let's see. I just got back from lunch. Did you get the type handlers working? And what route did you take? So all I ended up doing, Suddy, is if there's a pointer, then I'll just get the address pointed to by that pointer in order to read from it. So it just handles pointers by default automatically if there's like 2 levels of indirection. So, and yeah, we got the, I can kind of demo that for you again if you're interested. So let me, okay, so there's this global in this function, right? So if I say, let's say, are there any global variables in that function address. 404, did I copy the wrong address? 404.7A0. Oh, am I not? Oh, I think I used the decompilation before. Let me, local variables. Let me check out the MCP tool for getting variable names, because I might need to fix that too, actually. Okay, MCP server, get variable name, get variable data, but we need the get function variables. Yeah, so I need to add parameters. Oh my god, this is so gross. If response status equals success. Let's see. This is like off the screen and this font's super huge. Local variables. Oh my god, this is so gross. Why did I do it like this? Okay, let's refactor this a little bit because this is really bad. R string. I can just do something like this, I think. Even though this looks really bad. Okay. And then I'll do, sorry, it's just like really hard to, global variables. It's really hard to work with this at this size, but I want you all to be able to see it. So okay, let's just do like the exact same thing. Why can't I escape this addition or this append? There we go. Okay, result string is like that. Who needs new line wrapping? Yeah, the drop was a little bit too heavy. Okay, okay, that should fix that. As you can see, my code is pretty hacky sometimes. Okay, that should work. All right, so let's fix this, and by fix this I mean create a new chat session, and then it should just work, I think. Are there any global variables in 404.780? Okay, I might need to do something else because that should have returned it properly. Prototyping. What the hell? I didn't return my, okay, maybe it needs to like reload the tool somehow, but I didn't have to do that before. All right, auth 200, that's good. And then we'll do a new chat. Do you play any games? If so, have you checked out Claire Obscure? No, I haven't. What game is that? Or what's it about? Wait, does function have any global variables? Hell yeah, that works. Okay, so then I can say like, can you, I don't know how the MCP server would organically do this. Can you retrieve the data pointed to variables to figure out their purpose? All right, see study, this is it working basically. So I was able to acquire this service list at this address, at the given global variable address. And then these are commonly associated with backups, antivirus, and database services. And then I can basically just say like, can you rename these global variables, or can you the use of this data based on the full context of the function for, and then let's just give the service variable name. Okay, so it's an array of service names. The function iterates over each entry for each service name and attempts to open the service, open service A, and then it uses control service. So yeah, I basically got all the context correct. So yeah. So I think like next time I could probably move that to being a post request, and then I could provide the number of bytes in the get request rest format. I don't think that would be a big deal. But like it'd be cool if the large language model could decide how many bytes to get from the global pointer. It's an RPG that's turn-based. It honestly gives me near vibes. If you like adventure, story-driven games, I highly suggest. Oh, cool. Yeah, I'll definitely check it out. Not fully up to date on MCPs, but are there any setups yet that handle obfuscated samples well? Remember her course saying that even minimal obfuscation would throw them off a while back. Yeah, so there's not really any good ways to handle obfuscation currently from the MCP side or the large language models. I think that's probably the largest hurdle that folks would need to overcome in order to make this like a viable service. And that's probably the largest issue with a lot of these obfuscated malware methods preventing like automated analysis and stuff like that. Having said that, even with like normal unobfuscated binaries, it gets confused pretty easily. So I think that's probably like a problem that's not going to be solved very easily, depending on how much smarter these things get. We'll see, I guess. But yeah, to answer your question, I don't really think there's any good way to handle obfuscation right now, other than maybe using like a service like UnpackMe or automated deobfuscation scripts or automation that you can write yourself. Ideally, you'd be able to get the large language model to write those deobfuscation scripts for you. I kind of tried that when I was messing around with these before. That would probably be like a viable way. But then you're basically like getting the large language model to write scripts that you're executing based on the contents of the database. And then there's been like a bunch of POCs that people have posted of basically using prompt injection in order to get code execution on the box, performing the analysis that way. So I don't really think there's a good solution right now for that. But yeah, really good question. All right, cool. So we can probably call it there. I'm going to push all of these changes to the GitHub. So let's see, git status. We did quite a bit today. Now we have the ability to rename global variables. We have the ability to acquire global data from those variables. It took me quite a bit longer than I thought, just because of the need to, and I'll clean some of this stuff up. Like this stuff is, this should just be the current variable name, etc. But having said all that, things are working pretty well. But yeah, it just took me forever to be able to get the mappings of the local referenced global variables within a function, within a provided function. That just took forever. So there's probably a better way to do it than what I was doing, but I don't know. Right, I saw that, the prompt injection stuff. Yeah, totally. So, but yeah, this will be up on the repo. Here, I'll just share the repo just in case you guys don't have it. All right, so there's the BinjaLattice MCP repo that you can check out there. I'll just clean up this code a little bit and then I'll push it there, but I don't think it'll take me very much time. I just want to do a few small edits, but yeah, good thing that we also fixed the Lattice client bug that was in the logger as well. I don't know why that was the case, but I'll have those changes up soon. Really appreciate you all hanging out for this long. I know the dev streams aren't like crazy interesting, but I think getting these tools in place so that we can kind of have more fun on stream with them is necessary. And I'd rather dev on stream with you all and hanging out than just doing it myself. So it's more fun that way. But I'm just going to play that ad one more time, and then we'll find somebody to raid. So again, there's the reason that I can do all these streams for free and put out all this content for free on our YouTube channel, etc., is because of this training that I do and all the other malware analysis services that we do. So I'm just going to play that real quick, and then again, we'll find somebody to raid. So 2 seconds. Hey everyone, my name is Joshua Reynolds, and welcome to the Invoke RE Introduction to Malware Binary Triage course. Throughout this course, you will learn to triage and reverse engineer malware binaries using a number of proven techniques. These include static analysis, which is the concept of analyzing malware at rest, and dynamic analysis, which is the concept of analyzing malware as it executes. We will also be analyzing network protocols used in malware command and control communications, malware obfuscation, packers and how to unpack them, process injection, how to write effective YAR rules to detect malware variants, and how to compare malware samples at a binary level. This course consists of 11 modules, each containing lectures and practical labs to apply knowledge that you have gained as you complete the course. We provide both video and written materials, so no matter what your learning style is, you can complete the course successfully. Thank you for checking out the course, and we look forward to teaching you. 2 seconds. I'll send y'all over there, and then I'll catch you next week. So if I don't talk to you, have a great weekend, great rest of your week, and appreciate you and appreciate you hanging out. So take care. Later, study. I'm going to kill the stream, so catch y'all later. If you're still here.